Good morning, everybody. Welcome back. Grade 8 and 9. It's Mr. Pito, a subject advisor in Mutao District, responsible for mathematics in grade 8 and 9. We will be continuing for our congruency similarity. Today, the focus will be now on revision, doing of questions now. Remember last time, my popular poster there of sign of loving maths, because maths is life, maths is language. For example, in this particular question, where they are looking for the area of the perimeter, just you understanding that when you talk about the area, the two-dimensional, the covered space or surface, and of course perimeter, the surroundings. So basically, mathematics is the language and relationship of concepts. Remember in congruency, last time we said congruency equal in all respects, a figure equal in all respects, particularly when we talk about the triangle here. You'll be showing these two triangles are equal in all respects. All three sides are equal. If that's the case, these conditions hold: side equal to side, another side equals to another side, another side equals to another side, which implies that even all the angles are equal. So congruency, they are equal in all respect. Same size, same shape. Same size, same shapes. Last time I gave you an example of me hands that they are of the same size, same shape, and you can think of a child and an adult. The adult's hand might be bigger and the child's might be smaller. That one will be talking about similarity. But if they are same in all respect, remember that is your congruency. So here, how can you prove triangles congruent? You look for three sides that are equal. As long as we can prove that three sides are equal, then the two triangles will be congruent. As long as in two triangles you can prove that there's an angle equal and the side included or between is equal and the angle outside equal, angle and the side included and an angle, then that means those sides are congruent. Those triangles are congruent. Those figures are congruent. And if they are congruent, everything else is equal. All the angles inside are equal. Another condition, your side, your angle, your side. If you have a right angle triangle, you've got a hypotenuse, and of course a hypotenuse, remember, is a side opposite 90 degrees. A hypotenuse and one side of equal length, that suffices. It means the two figures are congruent. And lastly, and then you have an angle and an angle equal and a side, then your conditions of congruency are covered. Let's see now in summary. Your two triangles are congruent, or your two figures, polygons are congruent, if the following conditions are met. We've just spoke about them. You prove that side and a side and a side. Then you know that those two triangles are equal or congruent in mathematical terms. Side, angle, and an angle. One pair of corresponding sides are equal and two pairs of corresponding angles are equal. Congruency. Condition 3, side, angle, side, congruency. Condition 4, remember right angle. If there's a hypotenuse, it means there is a right angle, because hypotenuse is a side opposite right angle. Those are the conditions. Now, what is more important is for you to remember the properties of your 2Ds, your properties of your quadrilaterals, so that you can see here, for an example, this side is equal to that side is equal to that side, this angle is equal to vertically opposite. So in proving congruency or similarity, these properties will be of a great help. Opposite sides of a parallelogram are equal. Opposite sides of parallelogram are equal. That's very, very important. Opposite angles of parallelogram are equal. So those conditions will help you in proving congruency. You can see here, for example, this triangle might be congruent to that one. Again, you would be required to prove that a figure is a parallelogram. All the triangles inside are congruent. You can only prove that if you know the properties of that particular quadrilateral, your four-sided figure. Right. The next one, the diagonals of a rhombus bisect each other. So if you've got a quadrilateral and you've got the diagonals bisecting each other, then it's a rhombus. And they bisect each other at 90 degrees. And again, we can see the upper triangle there, congruent to this upper triangle. That side equals to that side. That side equal to that side. Or we can say hypotenuse equals to hypotenuse. And any other side equals to the third side. Therefore, you'll be proving your congruency. Therefore, it's important to know your properties, your parallelogram, your rhombus, and of course, your rectangle. All angles 90 degrees, opposite angles equals opposite angles of parallelogram equal, as in this rectangle. And then look at this one. This side equals to that side. This side equals to that side, but only these two figures. So this top triangle is congruent to the bottom triangle. The top triangle congruent to the bottom triangle. The triangle on the left congruent to triangle on the right. Because opposite sides are equal, vertically opposite angles are equal, this side is equal to that side is equal to that side. So that is why it's very important to know the properties. Again, observe. Parallelogram, diagonals bisect each other. Rhombus, diagonals bisect each other, but at 90. Rectangle, diagonals bisect each other, but not at 90. And a rhombus and a square. What is in common between them? The diagonals. The diagonals from this corner to this corner, from this angle to this angle, two angles, diagonal. They bisect each other, but meet at 90. In a square. In a rhombus, the same. So it's important to remember parallelogram, rhombus, rectangle, and a square, the diagonals bisect each other. Except when we come to the trapezium. Trapezium, we know only two sides are parallel. Only two opposite sides are parallel, and nothing is equal. So it's very important. Then lastly, going to your kite. Your kite, the diagonals intersect at 90, sorry. Diagonals intersect at 90, but the longer diagonal bisect the shorter diagonal. Adjacent sides next to each other are equal. Therefore, here as well you can say congruence. This side equal. The bigger triangle on the left congruent to the bigger triangle on the right. This side equals to that side. That side equals to that side. The third side is common. So that's why I said it's very, very important to know all those properties so that you're able to, just here to remind yourself, side, angle, side. Side included angle and a side. Angle included angle and a side. One of properties just to remind yourself. And again, let's look at this one here. The first triangle, the rectangle, look at the top triangle and the bottom triangle. What do you see equal there? Remember, we've just spoken about properties of rectangles. Now we've spoken about properties of a rectangle. That side equals to this side because they're opposite. This side equals to this side because they're opposite. This side, which is common, therefore you've got your side, your side, your side. Then we can say it's congruency. Right? Again, when you look at this one, This side equals to this side. That side equals to that side. And the angles here equals to each other, vertically opposite angle. Therefore, side, angle, side. Side, angle, side. Now, I'll give you the opportunity to do the next three for this part one, and then we'll be joining again part two. The next three, just do them quickly, and then we'll come back to them.